Okay, so the last thing we did on Monday was to start talking about the mathematical expectations for random variables. And in this lecture, we are focusing on two things. The first one is the mean of the random variable, and the second one is the value. So I believe we went through most of the material for the mean. So we talk about the different names for the mean of a random variable. You can call it the mean of the probability distribution, the mathematical expectation, and the expected value. We can use the sign mu to denote the mean of a random variable. And since we also call that the expected value, we can also use E of x to denote the mean of a random variable, or the expectation. Okay? So we went through these examples. We defined what is the mean or the expected value for both the discrete and the continuous case. We discussed these examples. I believe I give you a bonus point for the exam if you are able to solve this. 2 points if you solve it correctly. 1 point if you try. Okay, so I'm going to be adding those points by the end of the week. So you're going to have that point if you didn't solve it correctly for the next exam. If you did solve it correctly, then you will have 2 points. Okay, so we also talk about the cases in which you have a function defining the value of the random variable. And we discussed one of the cases with this example. And I believe that was the last thing we did. Okay, so for today, we are starting from here. And let me pass the attendance sheet. So, again, what we are doing in class is we are building, we're going step by step. We are using building blocks. So we started discussing the case in which you only have one random variable. Now we are extending the concept of the expectation or the mean to the joint, discrete, or density function. Okay? So that's what we have here. We have the mathematical expectation for the case of two random variables, x and y, with joint probability distribution f of x and y. Okay? And we define that the mean for the joint distribution as is here. For the discrete case, you still multiply the value of the probability for the function times the value of the function, and you sum those amounts for x and y. That's for the discrete case. You do the same thing, but for the continuous case, you need to integrate, again, the value of the function times the probability for those values of x and y. Okay, so again, it's the same concept. Now we are extending it to the case in which you have a joint probability distribution. So let's look at how we can solve this problem. So here we have x and y, both random variables with a joint probability distributions indicated in the table. So as you can see, x can have 3 values and y has 3 values as well. X goes from 0 to 2 and y goes from 0 to 2. And the values we have inside the table are the joint probability for, in this case, let's say 0 and 0. The joint probability is 3 over 28. And this, you should be familiar with this type of table already because we have been using it in class several times. So again, the values of y are listed in this column. The values of x are listed in this row. And the values inside this square are the probabilities corresponding to each value of y and x. Do anyone remember what these numbers mean? Yes, this is the marginal for x or y. For y, correct. And these values here are the marginal values for the probability distribution of x. Okay, and we know that the summation of these values and these values should be equal to 1. Okay, so let's try to solve this problem. And what the problem is asking is, with this distribution that you have, this joint probability distribution, which is discrete for two random variables, what is the expected value? Okay, so we have a joint probability distribution and we want to find the expected value for this distribution. Okay, so let's use the definition from the previous slide. So by definition, (4.2), which is in the previous slide, we know that the expectation or the mean of this joint distribution for x and y will be equal to, are we using the summations or the integrals? The summations. And the reason for that is because this is a discrete distribution. Okay? So we look at the summation from x equals 0 to 2, and the summation from y equals 0 to 2 of x and y, f of x and y. Okay? So if you have your homework, please keep it until the end of the lecture. Okay? I will collect it at the end of the lecture. Okay? Why are we using g of x and y equals to x and y? Because that's the way it's defined. Okay? So our function is x times y. And the probability is given by the table. And those are the values corresponding to f of x and y. Okay, so let's look at this. So what do? You have to look at each combination of x and y and look at the summation of these multiplications of the value of the function times the value of the probability. So let's start with 0 and 0. So you have 0 times 0 times, what will be the value of f? 328. Okay, so we are talking about this specific value of the joint distribution. Plus 0, 1, 0 times 1. So we are looking at this value, 3 over 14. Then we have 0 times 2 times 1 over 28. Then we move to x equals 1. So we have 1 times 0 times 9 over 28, which is this number, plus x equals 1, y equals 1 times 3 over 14. We can consider the next value, but we know that the probability will be 0. So I'm not going to be adding that number. This probability is 0. So the only number that is left is this one. So the outcome for that one is x equals 2 and y equals 0 times 328. So from here you can see that this is 0, this is 0, this is 0, 0, and 0. So the mean for this joint distribution is 3 over 14. So I can go and list all the values for the function. So if you want me to do it, I can do it. I can go and put that one, and that one as well, but we don't need it because the function times the probability of 0 will be 0, which is also the case for the other items here. Okay, so the only one that is not 0 is this one. That's the expectation of this joint probability distribution. Any questions? So this is the case for the discrete. Okay. So basically this covered the material for the mean of a random variable and the mean or the expectation for a joint probability distribution. Okay. Now let's consider our second measurement. And actually, I consider two new, another one that is new or that haven't been mentioned here in this class. So we're going to talk about the variance and the covariance of random variables. And we're going to start by discussing the variance. So again, you remember that at the beginning of the course, one of the things we did was to discuss how to get the sample mean, the median, and the variance for a sample. Now we are using those concepts for random variables. So let's start by discussing what is a variance. So the mean or the expected value of a random variable x describes where the probability distribution is centered. That's what the mean does. Okay? You have a sample space, you have a certain number in your sample. You want to know what's the center of that population or sample. You use the mean or the expected value. Okay? But this mean does not give an adequate description of the shape of the distribution. Okay? So if you want to know how dispersed the data points are, you need to look at the different measurements. Okay? And that's why we use the variance. We also need to characterize the variability in the distribution. Okay? So in this slide, I present two different distributions or two graphs. These are histograms for two different samples, and the only difference between them, actually, this histogram shows two discrete probability distributions that have the same mean. So the mean for both of them is 2. So as you can see here with this line, the mean is described as the number 2. What happened? The shape of the distributions are different. And why is that? These two distributions, even though they have the same mean, they have a different variability. Okay? So differ considerably in the variability or the dispersion of their observations about the mean. So you can have two distributions with the same mean, but that doesn't mean that they are the same. Okay? Because variability also affects the shape of the distribution. Okay, so that's why we need to consider the variance when we study random variables. Okay, so the most important measure of variability of a random variable x is obtained by applying theorem 4.1 by using the function of x equals to the difference of the random variable value minus the mean squared. So that function basically is going to look at how far the random variable value is from the mean. It's a measurement of dispersion. Okay? So the quantity is referred as the variance of the random variable x, or the variance of the probability distribution of x. Okay? So we are trying to characterize the probability distribution of this random variable. We know how to characterize the center or the center of the probability distribution using the mean. We also need to characterize the variability. And we're going to use the variance for that. Okay, so we can denote the variance using this term. Remember, for the expectation, we'll use E of x. For the variance, we're going to use VAR of x. You can also use the sign sigma squared for the variance. In this case, we use x just to denote that we are referring to the variable x. But if you know what variable you're using, you don't need to use x. You can just use sigma squared. Okay? Any questions? So sigma squared, when you say sigma squared, you know you're talking about the variance. When you see sigma by itself, What does that mean? Correct. So we're talking about the standard deviation. Very good. Okay. So in here we have the formal definition. Select x be a random variable with probability distribution f of x and the mean of mu. Then the variance of x equals sigma squared, the expectation of the difference between the random variable and the mean squared. And for the discrete, we're going to look at the summation of that term for each random variable. For the continuous case, we still use the same term, but instead of looking at the summation, we're going to look at the integral. And again, the positive square root of the variance, sigma, is called the standard deviation of the variable x, or the random variable x. Okay, so the mean, the variance, standard deviation. So let's work with this problem. And here what we're going to do is just compute the variance for two different cases. So let the random variable x represent the number of automobiles that are used for official business purposes on any given workday. The probability distribution for company A is given by this discrete probability distribution. And for company B, we have another distribution, which is the second table. Show that the variance of the probability distribution for company B is greater than the company A. So for this problem, we're just going to use the definition for the variance, okay, which is very simple. And I want you to pay attention of what we're going to do now, because I have a lab here for you to work on the next problem. Okay, so the next problem is basically you're going to have to use this material to solve the problem. Okay, so pay attention. What would be the first thing that you need to find to get the variance? Right, you need to compute the mean. Why is that? Because that variance depends on the mean. So in order to get the variance, you need to compute the mean. So let's find the mean for the first case, which is company A. So mu.
When I hear variance, I just think the largest quantity minus the smallest quantity. I just see the difference between the largest. That's what I think.
No, that's the range. That's not the range. No. Variance is a measure of dispersion, and basically you look how far the outcome you have is from the mean. Okay? Okay, so let's look at the company A. So let's find mu, or the mean, for A. So that E of x. Anyone remember how to get the expectation for a discrete random variable?
X summation over
F of x times? Correct. So you have to use the probability for each outcome. You multiply that and you sum that for each outcome. So as someone else mentioned, or one of the students mentioned yesterday or on Monday, it's like computing a weighted average. Okay? So we're going to look at the first value of x is 1. And what will be the probability? 0.3, correct. Then for 2. And for 3 is 0.3. So you'll get the expectation for the first company, which is company A. Okay? For this company. Okay, so now we have, this is 2.0. So now we have the mean. And we can use the mean to compute the variance. So the variance for A is equal to bar of x. So this is equal to the summation from x equals 1 up to 3 of x minus mu. And what is the value of mu? 2 square times f of x. So this is how we define the formula for the variance for this case, because we know the value of the mean. And using this expression, we can find the variance. So this is equal to 1 minus 2 squared. The probability of 1 is 0.3 plus 2 minus 2 squared times 0.4 plus 3 minus 2 squared times 0.3. So the variance equals 0.6. Okay, so this is the definition of the variance. This is the value of mu. You look at the difference from each outcome from the mean. You square those differences or distances, and you multiply that by the probability. The summation of each outcome will give you the variance. Let's do the same thing for company B. Can you move to the next slide? She's writing. Okay. A couple of students still writing. So for company B, the only difference is that we're going to have an extra outcome for x. So instead of having values from 0 to 3, we're going to have values from 0 to 4. Okay, so I'll go to the next slide. Just to complete the problem, so we need to find, again, the mean for B, expected value for the mean. And for that case, you have 0 times 0.2 plus 1 times 0.1 plus 2 times 0.3 plus 4 times 0.1. Still get the same mean. Let's see what happens with the variance. Yes. Oh, I'm sorry. Sorry. Thank you for noticing. So we have 3 times 0.3 plus 4 times 0.1. And this should be equal to 2. Now for the variance, still have the same expression, but we go from x equals 0 to 4, x minus 2 times f of x. So this will be equal to 0 minus 2 squared times 0.2 plus 1 minus 2 squared times 0.1 plus 2 minus 2 squared times 0.3 plus 3 minus 2 squared times 0.3 plus 4 minus 2 squared times 0.1. And for this case, the variance is 1.6, which means that you have larger variance for company B, even though you have the same mean. Okay, so we show that the variance are different, the means are the same. There's another definition or an easier way to get the variance. You'll get the same number with just a different expression. I can show you how to get to this expression, but since we have a limited time, I'm just going to give you the definition. But if you're interested, I can show you how to get to this expression for the variance. So an alternative and preferred formula for finding the variance, which simplifies the calculation, is stated in the following theorem. So we have the variance of a random variable equals the expectation of x squared minus mu squared. Okay? So the only thing you're going to have to do is just to find the expectation. Instead of finding the expectation of x, you have to find the expectation of x squared. Any idea how to do that? So you know that the expected value of x equals the mean, which is mu. And for that you use the summation from x equals 1, I don't know, let's say up to 10, if you have 10 observations. And you use x times f of x to find the expected value of x. That's by definition. Okay, and we show that in class. If you want to find the expectation of x squared, then what you do is the following. You do the same thing, but instead of multiplying times x, you multiply times x squared. Remember the example in which we used 3x minus 1? It's the same concept. Okay, so you can get to this expression by using this expression. Okay? Yes, sir.
Does this work for the continuous one as well, or take it?
This is for the discrete. For the continuous, you do the integration. Same. Yes. So this is another way of getting the value. Okay? Okay, so the next problem, I want you to work in couples, like 2 or 3 per team on this problem. And basically what you're going to do is just find the mean and the standard deviation for this case. So you're going to have 10 minutes. 2 or 3. So let me know how many. Yes, I'll just basically have another way to
Well, yes. I'm just doing all.
Start writing the
Okay, so you have 10 minutes.
10 times 28, 11 times 4.5, 12 times 23, 13 times 22, 14 times 22, 15 times 27. Yeah.
All right, so
Do you mean variance or do you mean standard deviation?
standard deviation. Yes, it's the mean and the standard deviation. But you know how to get the standard deviation from the variance. So you need to compute the variance.
Oh.
Yeah. It's just the square root of the variance.
So make sure.
This number minus 4.5.
Because that's square, standard deviation is root of that.
Yeah.
Yeah, see. I like floating charts. Yeah, it's, you don't even think, it's like, it's skill. Ridiculous. There was, I was in the room. I'm just gonna little separately. See these ones? So it says these guys are talking 1.92, and I didn't read that. And not all of them have that. Yeah, not all of them have that. So I was just doing like, oh, I just spot. And I'm like, I'm doing this on medium. No, medium is like this random stuff to do. And I go, this one, like, then I read that and I'm like, come on, please. Yeah. Seen some other ones.
all the ones that have diagnosed with depression. I would love to work with that.
What is more time? Then start selecting the papers. You can pass the papers to your right if you're done.
I'm going to give you the solar agreement or something. He's like, no. Just need to start looking.
Yeah. We need to get on that.
Yeah. But I will have to say that there myself one more time, and I almost know what to do. If I hadn't procrastinated this long,
Again, what's your details? If you do something wrong,
I say that because I quit shooting and it's taken a lot of my time and energy.
I'll prefer you to.
So now it's like, oh, wait, I don't have to ask that. I have to do it.
Okay, you guys done? Do I have all the papers? Okay, so let's discuss the problem. So I guess the first part should be really easy, straightforward. The expectation, so you look at the value of the random variable times the probability, and you sum each outcome and each probability, or the multiplication of each probability and each outcome. So this is 0.08 plus 11 times 0.15 plus 12 times 0.3 plus 13 times 0.20 plus 14 times 0.2 times 15 times 0.07, and that is 12.5. You already got that one right? Okay. Now, to get the standard deviation, you need to find the variance first. So there's two ways that you can get the variance. The one that we discussed with the example. The second way that you can find it is by using this expression. Okay, so for the purpose of just showing that this works, I will use this expression. So to get the variance, I will use E of x squared minus mu squared. Okay, so this is from here. Okay, so what will be the first thing I will have to do? e of x squared, right? So to find that, this is equal to 10 squared multiplied by 0.8 plus 11 squared times 0.15 plus 12 squared times 0.3 plus 13 squared times 0.2 plus 14 squared times 0.2 plus 15 squared times 0.07. So this gives me the expectation of x squared. Now I need to subtract mu squared. So mu is 12.5 squared. And the variance equals 1.85. The standard deviation will be the square root of 1.85, which is 1.36. How many of you got it right? Great. Okay. So, any questions? Either way you do it, you will get the same number. Okay? So you can try it with the other expression. Yes, sir.
You're doing a shortcut method. I mean, I noticed you're doing a sum here, but there's no sum and stuff.
Because this is the expectation. The sum is here.
Oh, yeah, you're actually.
That is
Yeah.
correct.
Exactly. Any other question? So this whole term here, this term here is just for e of 0 squared, x squared. Okay, let me make that clear. So let me use a different color here, maybe. So this is this. Okay? Any other question? Okay, so let's look at the case in which you have a continuous random variable, which is this problem. In here, we have the weekly demand for drink water product is in thousands of liters for a local chain of efficiency store is continuous random variable x having this probability density function. Okay, and I want you to find the mean and the variance. So far we've been looking at examples in which you have only discrete random variables. Let's look at this problem with the continuous random variable. Okay, so x, let's find mu, which is the expectation of x. And what you do, you look at the integral from 1 to 2 of 2 times x minus 1 times x dx. You guys remember, you get the expectation, you have to multiply by x, which is the value of the random variable. And this term right here is f of x. Okay, so now we have this, then everything else is straightforward. So you just integrate this x squared minus x from 1 to 2 dx, and this will be x3 over 3 minus x squared over 2, everything times 2, and this goes from 1 to 2. And this should be equal to 5 over 3. So that's our mean. And again, this is a continuous random variable, so you need to integrate. Now let's look at the variance. So For the variance, I'm going to use this, which is the shortcut. So this is e squared, x squared, sorry, minus mu squared. So the first thing I need to do is to find the value of e x squared. And as I mentioned earlier, what you do is e of x squared will be equal to 2, the integral from 1 to 2, x minus 1 times x squared dx. So to find e of x, or the mean, you multiply times x. To find the value or the expectation for x squared, you multiply by x squared. So solving this, it's basically the same integral. You find that this is equal to 17 over 6. So now we have this term. We have the mu, or the mean. So we can use this term to find the variance. So from here, we get 17 over 6 minus 5 over 3 squared. And this is equal to 118. And that's your variance. Any questions? So it's basically the same thing we've been doing today, but this case is a continuous random variable. We have the density function for the variable x, for the random variable x. We need to know, we know that it's a continuous random variable, so in order to find the expectation, we need to use the integration of the function times the value of x. We find the mean. Then for the values, we're using that expression. We need to find the expectation for x squared. We do that here. Then we can substitute this number and this number to get the values. Any questions? So that
It's quite simplistic, but how did you add in the x variable and the normal variance at first? And here you have 2 parentheses x minus 1 parentheses x. The original function shows no x.
yes, but by definition, in order to get the expectation, you need to multiply the function f of x times x. The summation, the expectation, is the summation or the integration for continuous of the function times x.
You have to multiply no matter what.
Yes. So what we do here is for e of x, we multiply times x. For e of x squared, we're multiplying times x squared. Okay? Okay. So that covers the variance. Okay? So remember what we did for the mean? We also use the next case or situation to evaluate the mean. So let's extend this concept of the variance of a random variable x to include random variables related to x. Okay, so this is the same thing we did for the mean. For the random variable g of x is the function. The variance is denoted by sigma, to be sigma squared here. Sigma squared of g of x, and it's calculated by the means of the following theorem. So when you have a function defining your random variable, remember 3 times x minus 1 something that basically adds something to the random variable, we can use this theorem to compute the variance. And essentially what we are doing again is looking at the difference from the random variable, in this case is defined by the function, minus the difference from the random variable to the actual mean. And squaring that and multiplying that by the function probability. So this looks kind of messy, right? But when you look at the problem itself, it's not that difficult. So again, the only difference that we have here is that instead of looking at the value of the random variable itself, we have a function. So let's look at the example. So what we have here is a function g of x that defines the value of the random variable. Okay? So calculate the variance of g of x, which equals 2x plus 3, where x is a random variable with the probability distribution presented in the tables. So again, let's define what the variance is. So the variance is sigma squared, in this case for g of x, and that is equal to the expectation of the difference between the value of the random variable evaluated in the function minus the mean for that random variable squared. Okay, so let's first find that value for the mean. Okay, so we need this number first. The expectation for that random variable. So mu of 2x plus 3 is going to be equal to the expectation of 2x plus 3. Which is the same thing we did for x squared. Now instead of having x squared, we have 2x plus 3. So this is equal to the summation from x equals 0 to 3, which are these numbers. We know that we have 3 outcomes for this random variable. 2x plus 3 times the probability. Okay, so if you solve this, you have 2 times 0 plus 3 times 1/4 plus up to 3, so you have 2 times 3 plus 3 times 1/8. And that will be equal to 6. So what you're doing here is, you know that your random variable goes from 0 to 3. So you substitute 0 first in here, and you know the probability of 0, 1/4. Multiply that plus same thing for x equals 1. So I'm putting those dots here to tell you that you go from 0 to 3. So the last term, you have 2 times 3 plus 3 times the probability of 3, which is 1. And that mean equals 6. Questions? Yes, sir.
How do I notice? How do I figure out which one to use? Either that one or the one before. They worded pretty similar.
For the mean or for the discrete?
Like the other formula.
Oh, the discrete continuous.
Discrete or continuous? Okay, so in order to identify if you have the discrete or continuous, in this case, you know that your outcomes, you can count them. They will go from 0 to 3, and you have a probability for each outcome. That means that you can count your outcome. That is a discrete distribution. If you had, instead of x equals 0, 1, 2, and 3, you have x greater than 0. Right? That means that your range is continuous, so you will use the integration. Is that clear?
Like continuous uses an equality.
Exactly. Exactly. Any other question? Yes.
Could you skip a definition behind mu of v of x? Like, is that how you find mu of v of x?
mu of p of x. That's what we're doing here.
Yeah, we have. This is just the.
This is just the mu.
We haven't finished.
Yeah, we haven't find the variance. So working on this. So this mu of p of x is mu of 2x plus 3, which is the expectation of 2x plus 3, which is how we define the function of the random variable. So instead of having p of x here, we have a function for our random variable x. And that's what we plug here, because now the random variable is defined by a function. Okay, so let's try to finish this problem. So we know how to get the mean. Okay, and again, our random variable is not x, it's defined by g of x, 2x plus 3. So we got the value for the mean. Now let's find the variance. So we have sigma squared of 2x plus 3. And this is equal to the expectation, this is coming from here, of 2x plus 3 minus mu of 2x plus 3 everything squared. We know mu, so we can basically put a line here. So we can work with this expression. So we have e of two x plus 3 minus 6 squared. And this will become the expectation of 4x squared minus 12x plus 9. So this is coming from solving this and the square. So you're going to have 2x minus 3, and then the square will give you this. Now we have the expectation of this expression, this polynomial. So in order to get the expectation, you do the summation from x equals 0 to 3 of f of x times the probability. So you need to find the expectation. So you found the mean for your function, but you're substituting that mean inside the mean of the difference squared. So this becomes another mean or another expectation. So in order to find these expectations, you know, if you have a discrete random variable, you need to look at the summation of the third times the probability. So if you were to solve this, what we are trying to say here is, let me go to the next slide. Try to write it here. So for x equals 0, you will have 4 times 0 squared minus 12, 0 plus 9 times all this times 1 over 4 plus 4 times 1 squared minus 12 times 1 plus 9 times 1/8. Then you go to the last term. You have 4 times 3 minus 12 times 3 plus 9. Yes. Thank you. And 1 over 8. And all this will be equal to 4. And that's your variance. Okay, so this term, when you solve it, you have to substitute for each x and multiply times the probability. For the 4 outcomes that you have from 0 to 3. Okay, so this kind of complicated, right? So again, what we're trying to do here is we're dealing with the mean and the variance. But we have different cases. First, we have expressions for discrete, expressions for continuous. Then we also have expressions for random variables by themselves, joint distributions in which you have x and y. And we also have the cases in which you have the random variable defined by a function, which is this. You have g of x defining your random variable. Okay, so you have the discrete and continuous in 3 other cases. That random variable by itself, joint distributions, and also the function defining the random variable. Questions? Okay, so there's another example here. Maybe this will, this is for the continuous case. So this is a discrete case. Let's look at one problem that try to find the variance for the same type of problem. This is discrete, yes. But the next one is continuous. So here again, look at the range for the values of x. It will go from -1 to 2. And I'm sorry, this shouldn't be here. So please, yeah. So that shouldn't be there. Yeah, so take that out of the slide or delete it. Yeah, and that's kind of confused. That's why you were thinking there was a discrete. No, that's not part of the problem. Okay? So take that out of the problem. And I want you to find the variance. This is a continuous distribution for the random variable that is defined by this function. G of x equals 4x plus 3. So again, this is a problem that we already worked if you look at slide number 13. So in slide 13, you have that the mean of 4x plus 3 equals 8. Okay, so we're going to use that information to find the variance of 4x plus 3. So this is equal to the expectation of 4x plus 3, yes. So this equals the expectation of 4x plus 3 minus 8 this is at 8 squared. Okay? So we are following the definition. Now we have to use the continuous case. So this will become the expectation of 4x minus 5 squared. So this is equal to the integration. What are the ranges or the numbers for the range? Correct. So we go from -1 to 2. 4x minus 5. What is f of x? Correct. A square over 3. Yes, this is square. dx. Okay? So, to get to this point, everything is fine. Now, what comes next is more calculus and math. Okay? So, this is going to be equal to 1/3 the integration from -1 to 2 of 16 x to the 4 minus 40 x cubed plus 25 x squared dx. And if we solve all that, after 30 minutes, you'll get this. Okay, so again, for the purpose of the exam, you're able to state the integral like this, should be fine. Okay, because this is, I know this will take a lot of time. Okay, so you don't have to solve. Yes.
Putting the integral on that's credit.
Well, in the exams, if I put a problem like this, I will let you know. You don't have to solve the integral. Okay, so just show me the expression. Okay.
Solving the integral can be 2.7 credits.
Solving the integral, if you remember you have 1 hour, if you want to spend 20 minutes doing the integral, it's gonna cost you. Yeah. Yeah. But I know there's some calculators that will do that in 30 seconds. Okay, so that's why I don't want you to spend time if I know the other students have the calculator that can solve it in 30 seconds. Okay? So one more thing to cover in this chapter, and that is something that we haven't talked about in this class, the covariance. But I'll stop here today. Don't move. I need to tell you about what's going to happen next week. So next week I'm going to be in a conference. So I'm going to be out Monday and Wednesday. Okay? So don't be, you're going to become very happy. So I'm not going to be here. The plan is the following. I will record the lectures. So you're going to have a lecture for completing this part of the class and also a lecture on discrete probability. Those 2 lectures are going to be posted on video online. You'll be able to access those lectures on your computer or your iPad or in your iPads. So, but this is the catch. You're going to have a homework that's going to be due after next week. Okay? I'll probably put it on Monday. So, just make sure that you watch the video and you complete the homework. But you're going to have the assignment and you're going to have the video posted this week. Okay? Any questions?
So, no class this week, but it's
If you have your homework, please submit it.
Stefan, you can't have my test. It's okay.
You check tracks. I think I already changed the score.
Okay.
But I don't have your exam with me right. If you want to pick it up now, sit there.
Is your office here?
No, it's in the second floor.
Second floor?
Yeah. Oh, you can go later. I gave you the full credit.
The full credit?
So you should, I think you got it.
100. Okay, that's good.
Thanks. Thanks. Yes, it's a homework for today, right?
Yes, and that's a girl that wasn't here. She gave it in.
Yeah, don't do that.
I can't.
No, you can't do that. I'll take it. But if she's not here, she needs to show some.
She did the homework with me though, every day, 2 days earlier, so she had to complete it.
Okay. Yeah, I know, but if she's not here, it's supposed to turn some in. Yeah, but it's not your fault. I understand. Yeah. Yeah, but
Oh, it's just an errand. So.
yeah, I know, I know. So I mean, then
Can I sign in on the attendance sheet?
There's like something for him, another way of doing something.
Or is it over there?
Right? So, alright. Fun spot.